Right, so in this video we're just going to take a quick look at things that are coming, and the most interesting one is the Altitude Angel Project Arrow. It's part of the UK's sandbox for the CAA. They're working closely together, and it's about creating an air corridor. So we're just going to talk about this air corridor and what we know, okay, and then some of my thoughts on some of the tricky bits they've got ahead of them. They've got ahead because it's quite interesting. Here's what we know, okay. It's down in Reading. It's in the Thames Valley. They have 3 towers, okay. It's 8 kilometres long. It's 3 towers, which means each tower has got to cover approximately 2.6 kilometres of space. The air corridor is 500 metres wide, so if we've got our 8K here, and this is a top-down view, okay, it's 8 kilometres long, okay, so we've got, there's 3 towers in there, okay, and that's how it works. And this is a side view, this is the top-down view. Okay, and it's only 500 metres wide, interestingly. Okay, and that's quite interesting, and I'll get to why that's interesting in a minute. So, they've announced it, they've said this is what we're going to do. As I understand it, none of this kit's been tested yet as such. They're starting their trial flights in the autumn, which means they'll have limited flying because of the UK weather. It goes across the M4. There is a commercial area that it does fly next to as well. So it's from countryside to a rural area, and I believe there's a train depot or something at one end nearby as well. So, you know, they're covering all areas where people are going to want a UTM service. So we're going to say a unified traffic management. I'm not going to use the word unmanned because I don't like it. And if it's not unified, it's not worth squat. So we're assuming it's a unified traffic management system. Okay. That's what we're assuming this is. Okay, because a UTM that only does air traffic for drones is nigh on pointless. Now, what we do know is the 3 towers. We've said that. Now, what we do know about the towers, okay, and this is public knowledge, so I'm not saying anything that's not been said anywhere else. It's got an RF sensor on top of each one. Now, they have also got cameras. So we've got cams as well. We've got cams. We'll get to the cameras in a second. The basic idea is, okay, the basic idea is you can be a company and you want an air corridor setting up. But they'll come out, you put down your towers, and then basically you're going to be able to fly your drone from a depot over here. You're going to be able to fly your drone up, you're going to fly through the air corridor and get to your delivery place, for example. Just an example, everyone talks about drone delivery. I can add fuel to that fire. And that's what it looks like. Now, the idea is, of course, that let's say I was going to draw a plane then, and I thought, no. I might have to try and draw a helicopter though. But the idea is basically, if there is an air incursion of any kinds along the air corridor, okay, so let's say we've got another object. Here's our drone, this is our drone doing its thing, it's flying through the air corridor, and let's say there is something else detected here, right? There is another detection, something here. It is the system that the RF, if it's giving off an RF noise, a radio frequency, is it giving off RF? If it is, it's probably another drone. If it's not, the cameras are there to detect. Okay, so the cameras are there to sense what it is and go, right, what is it? And then they will tell the drone to either go further out or further across this way and avoid whatever is here. Okay, that's the basics of how it will work. Okay, now they're saying that nothing extra has to go on your drone, so there's nothing extra on your drone. Basically, they're going to send some sort of command, and it'll say to the remote pilot or the or your company, if you're monitoring 5 aircraft, you'll get a notice come up and it'll go, aircraft number 5, you need to divert please to heading 360 and maintain speed. Okay, and maintain your height. They might tell you to adjust it or lower it, depending what's required, depending what this is. Okay, so it's interesting, and it's not been, from what I understand, they've not done this yet. Now, I'm going to take this off and we're going to look at the subtle niggles, if you like, or my bits that I think are going to be interesting. I think it might be easier with a top-down view, just because you can't really do what's going to go on here with this view. We'll do a top-down view now, but that's the basics. It's 8 kilometres, and we'll do a top-down view now. Right, this is our air corridor as if we're looking top-down on it. Right, so we know we've got our 3 towers with our RF and our cameras on them. Okay, these sense radio frequencies and everything else. We know somewhere we are crossing a main road. Well, we're actually crossing the M4 actually. We don't know whereabouts, but we know it's there. And we know at one end there's the commercial dash. This is all the commercial area here, and this is so they can get feedback on what's going on. And again, the idea is, you know, Bruce over here has got his drone business and he wants to deliver to the commercial sector. The idea is that the drone's going to be able to fly through this network. So it's 8 kilometres long. Okay, so all this is 8 kilometres, and it's 500 metres wide. Okay, so it's 500 metres wide. From there to there is 500 metres. That's the idea. The idea is you can get your drone, you'll set your route, drone flies across here all the way to your point where you want to be. Now, interestingly, you've only got 500 metres to play to work within. Now, to keep 1,000 feet, okay, from other aircraft, that's about 300 metres. Okay, so if there was another aircraft detected here, for example, and the system will send Bruce a notification, you need to go around, you would have to go all the way over. Okay, all the way over here. Because it's always the unmanned aircraft yields to the manned aircraft, always. So this one here is going to go around. Okay, that's all good and fine. Okay, I like the theory, I like the idea. Now, what we're going to do is now talk about drone detection. Okay, and I'm going to change this slightly. So we've seen this is how they plan on doing it. Just to be clear, I'm not sure that 3 towers, each tower's 2.6 kilometres apart. For me, from what I've seen, I don't think that is going to do it. I think they're going to need more towers. Okay, I can't really say too much about what systems I've seen. I can only give you a general overview of how drone detection works. So now we're going to change this up. Okay, let's do drone detection. Okay, and then you will begin to understand why I think they've been for a couple of challenges, not insurmountable. you know, and we're good. So here we go. Now, there are quite a few drone detection systems out there, of which I know about 4. So, let's pretend this is the area you want to protect, right? Let's pretend this is an area you want to protect from drones, okay? If you wanted to do this, okay, and we can make it, we can be nice, but we can make this 1 kilometre wide, and let's say it's 3 kilometres long. So it's going to be, like I say, it's 1 kilometre wide. Okay. So from there to there is 1k. Okay. You would actually need today, as my brain understands it, and someone out there is going to say I'm wrong, you would want an RF sensor here and here, and then you're going to want one about, you're going to want one around every, you might get a kilometre if you're lucky, okay? You might get 1 kilometre between each of your sensing towers, okay? We'll put 3 in, okay? Would be nice. So there's 6 in total, okay? So each one can cover 500 metres in, and they're covering so far across. And then what happens is that typically, with most drone detection systems, they all have RF sensors. Okay, so we've all got RF. This is the most basic drone detection system there is, right? All it has is a radio frequency detection. So basically, as your drone flies currently, if you're flying a DJI, you're pumping out a lot of RF noise quite loudly, okay? That's what these sensors can track. And they can track your route through, and they can track it on the outside. They don't track on the outside as well as they do on the inside. The reason is they need 2 towers to sense the aircraft. If you're inside the network, so if you're inside the 6, you can get a really good track, okay? It can be really solid, it will really lock in, and literally you can look at it on a map, and step outside and you can point to it. They lock on that well. However, if you're on the outside, it's not so good. The closer you are to the tower depending upon what the RF node is like. Some nodes are better than others, some makes are better than others, does depend. They're not necessarily cheap. It depends what you're after. Now, a lot of people go, I want to fly BVLOS with my DJI Mavic, or I want to go further. So people that don't want to stick to 500 metres, they want to do 5 kilometres. What they do is you go in and you set up the FCC frequency, more power output. If you do that, this system loves you even more because you're easier to track, because you're pumping out that higher bandwidth, that higher noise. Okay? Now, and if you're pumping out that higher noise, well, they can track you easier. Now, so they can see the drone once you're inside here better. If you're here, it's a little bit harder to see you. Can they see where the transmitter is? If you're inside the network, there is a good chance they can see where you're stood with the transmitter. However, if you're on the outside and you're over here, here, or here, and you're stood, because of the power output, you can be detected. Now typically, again, you want 2 towers to be able to see you, to locate you. It is possible, but it's not perfect. For example, if they had this at Gatwick, and the drone was not inside the sensor network, it would be hard to tell where the pilot is. This is where you've got to become a bit of an investigator. Get a map out and look, where would you fly from? You know, you go to the local parks, you would literally just go and do that, and you'll probably find the pilot quite simple. You know you're in this part of it, you know to go there. Okay? How far can these sensors reach? I would suggest that 2.6 kilometres is pushing it. I don't think this one here could do 2.6k down here somewhere. I don't think that's possible. I'm happy to be proven wrong, by the way, in my experience. Now, and that's a very basic RF detection. Now, you can add cameras. Now, what can a camera see? Let me put it like this. A ground camera makes a drone camera look crap. Okay? Those telephoto lenses and everything, you know, people think drones can spy on people. Well, those people seem to miss the fact that, you know, you can go and buy a big lens. You don't need a license to buy a lens that can photograph something 2 kilometres away and you can see it as clear as daylight. There's no license for that, and that is more intrusive than any drone will ever be. Okay? People forget all this. You know, we've got to register our drones, but this camera that's filming here, I could stick a lens on it like this and I could shoot something 1 kilometre away. You know, you don't need a drone to spy on people. And that's just a bit of a rant, sorry, off topic rant, sorry. Anyway, so what do these cameras and how do they work and how do they detect? What happens is the RF sensors pick up an object here, right? Let's say you're inside the network, but you only hear the RF noise coming from the drone. You don't know what it is yet. Now, it is possible with an RF node to go, that is an Inspire, because there is a certain footprint from the RF noise. So you can say that's an Inspire. You can say that's a Mavic 2, or you could say it's OcuSync 2. Now, the camera, what the cameras can do is they can tune in, the RF sensor says there's something here. The camera then points to the object, takes the photograph, and then identifies it. Now, the kicker is, it has to be in the system, okay? Because you have to know, is it a drone, or is it a glider, or is it something else? Is it a microlight with a radio transmitter going on? The camera does need some sort of system in it to identify the aircraft. Now, AI is a pain in the, there's a word we could put in there, to train. Because to train AI to see the drone, you have got to fly every type of drone you can nearest damn it get your hands on, then fly it in every kind of weather condition. So it's got to be flown on a sunny day, a cloudy day, a very overcast day, at night, so the camera can identify what it really is. And you kind of got to teach it, because it's AI, you've got to teach it what to do. Some cameras are very good. There are others that are not. Okay? Now, are there any other sensors that you could put into a drone detection network like this? Yes, there is. There are several. What you can have is you can have radar. Right? Radar. Now the radar systems, they are interesting. They can cover a very large area. Okay? And if you go up against a radar, the chances are, with the camera, the RF and the radar, the chances are they're going to see you. Okay? This kind of system now is one of the ones where if you want to beat this, you're going to have to go outside the box. I'm not going to tell you how to do it because, you know, there's certain things that shouldn't be. I don't need to tell you. But if you've got the camera, you've got the RF and you've got a radar, right? Don't care where you are, that radar is probably going to see you and track you as clear as a mug. Okay? You know, you're going to stand out like a big black blob on the screen. There's no escape from this. Okay? For the most part, there are ways to escape and there are ways to be hidden. But basically, if there's a camera, you've got RF and you've got the radar, there is a 99.9% chance, unless you know how to do some very clever avoiding, you're detected. Okay? Now, right, so, there are people that are going, aha, well I fly on 433 megahertz, I fly on 868 or maybe something else. The systems can see you. Okay, so drone detection systems can see you on any frequency. And if you've pumped up the output on your drone, okay, to FCC, you're more likely to show up than someone else. Okay, but that's a typical drone detection system. That's how it works. Multiple nodes. Between them, they can see where you are. If you're on the outskirts, okay, so if you're here and you're flying, these two will see you, and then they can see where the drone is and they can track it. Okay, can they see where the pilot is? That depends. You know, the cameras are really interesting because, to be honest, you need the camera to be able to confirm what's there. And the camera systems tend to be dual systems, so you have a small camera and a bigger camera next to it. And then the RF sensors, depending upon what RF nodes they're using, depends how sensitive they are. Radars pick up everything, by the way, so that means birds and everything. So if there's a flock of birds over here, okay, so we've got a flock of birds over here, the radar will see them. You then know there's no RF noise, but you still have to confirm what it is. Then these cameras, okay, can confirm what it is or is not. Okay, and that's basically how it works. Now, with the Altitude Angel system, with them only having the 3 nodes, can anyone spot the slight niggles? Okay, don't get me wrong, I don't know the spec of their RF gear, so it's hard for me to say. Okay, and I don't want to sound like a downer on anything. Okay, so we'll get rid of this. We'll get rid of that. We've now got the 500 meters. Right, so we've now got the 500 meters wide corridor. Okay, we've got 3 towers. Okay, they're 2.6 kilometres apart. We know they're crossing the M4 at some point. And by the way, anyone that's ever going, you can't overfly main roads. The CAA is saying, yes, you can overfly the M4. One of the busiest roads I know of. I've been stuck on that many a time. I also know, as we said before, we've got the commercial area at one end as well. Now, what's going to be interesting is, and this I know from experience, each tower's got an RF sensor on it, we know that, and they've got cameras. Okay. The interesting thing about radio frequency, don't care, right? When you're flying your drone, right, so you've got your drone, we're now flying our drone, not sure if green's going to show up very well. As we fly our drone across here, right, what's really interesting about radio noise off drones, even at 60 metres high, and let's say they're going to say we're going to fly at 60 metres and above because that's sensible. They might actually say to fly across the M4, we've got to be 18 metres or higher, because if you want to get across the M4 and you have a failure with a multirotor, you want the momentum to get you across the M4, and that's the important bit, okay? You've got to get the momentum. So at 80 metres or higher, you know, let's say the M4's, I don't know, 24 metres wide, and if it fails, the worst place to fail to land on the M4 would be sort of before it. If you fail here and you're above it, the chances are you're just going to go over it. So it is really understanding the risk. Is not actually failing above the M4, it's failing before is the problem, and then it's just whatever's here is the problem for you. So we've got our 3 towers. Drone detection. RF signal is going to bounce like absolute crazy, right? The lorries on the M4, right, now, you're not going to believe this, right, but this traffic, they're going to have to do some very clever learning about what goes on with RF signals with traffic. Big metal containers, they may be at ground level, but as the drone passes over here, that radio wave is still going to hit this wagon, okay, these fridge container units and other stuff, and they're going to bounce the signal all over the place and could give false signals. Now obviously this is why they're testing and why they're testing over a road. So big thumbs up, you know, they're not doing it the easy way. The easy way is across no roads, no buildings, where the RF signals, again, if you're flying near the commercial area, the RF noise is going to bounce off all these buildings. And you have to eliminate the RF noise from these buildings. So all buildings give out radio frequency, 2.4 gigahertz. You know, most people got mobile networks everywhere. It's just going to be an absolute minefield. And I really hope that they can tune all the crap out and get rid of false detections. I do wonder if 3 towers is going to be enough, although each tower has got cameras. So I like the theory. But basically, the very basic thing on this is, it's a drone corridor, and it's the Altitude Angel, and it's Project Arrow, but basically, all it is a drone detection system. In its most basic form, and I'll probably get abuse somewhere, it's just a drone detection system. It's just a way to monitor a drone going from point A, okay? So we're going from A, and we're going to point B, okay? I would suggest, and again I'm going to get shot for this maybe, that any company that's been and got their drone detection system certified, and in the UK what happens is you design a system, you send it somewhere quiet, well, quietly known about, should I say. They then send multiple drones at it, and then they rate your system accordingly. So if you see everything, you get top marks. If you can only see a phantom, you get a certain level, and then if you can only detect certain drones, you know, can you detect that model flyer? What's going to be interesting with this is, can you detect a model plane flyer? Now I'm thinking the reason why the 500 metre range, okay, wide, I think the limitation might be what the camera can see. I could be wrong. I must be wrong. I must be wrong because there's 2.6 between each one this way, isn't there? So I've got to be wrong. It can't be what the camera can see at all. So that's already wrong. I'm surprised the RF nodes can see. Each node's got to be able to see over 1 kilometre, because you would hope there'd be a bit of an overlap at 2.6. So at 2.6 kilometres, you'd hope each node can go a little bit further, so you get your overlap. But yeah, I think Altitude Angel's got a cracking kind of idea if they can eliminate the RF noise issues they're going to get. You know, and it is basically drone detection in its most basic form. So if you're a company that's made a drone detection system and heard about Altitude Angel's Project Arrow, to be honest, right, and this sounds terrible, I'm going to give loads of people the chance to create their own UTMs, right, and it's true, you can just create a UTM, you know, all you need to do is have a way to be able to take drones and track them through the corridor. Now, how long is this system going to exist for? Well, here's the kicker for all of this, right? This can all disappear, okay? There is a day coming when well, not the buildings, I should leave the buildings in place. Eventually they'll be destroyed, but all of this can go, right? All of this can go. What this is all building towards, right, is being able to track aircraft and build the ConOps system, okay, right? How are you going to communicate with your clients, right, through all of this? All this can go, all of this 500 metres and everything else. And the reason why is very simple, because in around 4 years, maybe 5, as soon as electronic conspicuously as soon as we get electronic conspicuously, I don't think I need to spell that. I'll leave it as conspic. As soon as we get electronic conspicuously, as soon as this comes in, right, And we can see everything in the air, right? Be it a drone, it can be paragliders, gliders, hang gliders, paramotors. As soon as we can see everything, as soon as the CAA can bring this in, okay, electronic conspicuousy, as soon as we can see everything else, all of a sudden you don't need the RF towers anymore, okay? To have a traffic management system, a unified traffic management system, you don't need to know, because it means that everyone can see everyone else and take avoiding action, okay? We just need this standard, okay? But we don't just need it for drones, we need it for everything. Upon this day, not only should airspace get safer, where gliders will not hit fixed wings and fixed wings won't hit gliders or microlights or anything else, upon that day we should be able to see everything in the air, then that's great. And all those companies, right, all those people that pay for their ADSB, right, not to show up on things like Flight 24, right, the days of you staying hidden as well should be gone. Okay? Because it will be the law that everything's got to show up. The only thing that won't need to will be military and probably police. But they'll see what else is out there because they'll have a device in the cockpit and they'll be able to see where everyone else is, so they can then avoid us because obviously we cannot see them. So it'll be down to them to do the avoiding. But that's what's coming. And when electronic conspicuousy comes along and people are going, oh, you'll be able to have a unified traffic management system, it will beg the question, will we? Because with all the open source stuff, we'll be able to have, you know, tablets running in the system. You should be able to see everything in the air. Perfect. And because as the pilots, we are responsible, okay? We are the ones that are responsible. So if we've got a tablet and we can see everything that's on it, will we need a traffic management system? That's the big question. You know, I do think some companies that do mass deliveries, they will definitely want some sort of traffic management system. But for the rest of us, you know, I want to fly and do some mapping, I need to fly 5 kilometres out or 10 kilometres out. When electronic conspicuously comes along and we can all be tracked, technically, I should just be able to go and do it. There should be no more of this, of the 500 metre visual line of sight rule or more. You know, if you can see what's going on around you, then we should be able to go further. And it could open up a lot of things. But until we get this all sorted out, we've got to stick with other ways. Okay? Just my thoughts. And I do think, don't get me wrong, Altitude Angel, you're doing some stunning stuff. It is 8 kilometres. It does require towers for detection for now, you know. But if you need to learn about something, proof of concepts, and in the future how you're going to be able to detect everything in the air, you know, this is where you start. This is your starting point. Got our RF towers, we can see, we can send the drone around, we can do everything we need to. It is really good. And I do hope, you know, that all the testing goes well. And I hope some of my bits are wrong. I'm hoping that the RF issues aren't going to be as bad as I think they will for them. Okay? But yeah, and drone detection. Do the systems exist in the UK? Yes, they do. I've not touched on the jamming because jamming is subjective. I'm not going to say too much. GPS jamming, you know, jamming drones, jamming the drone. I just, yeah, you know, you set your drones up correctly, guys. In the UK, they'll never be allowed to shoot them down, I should think, because you don't know where it's going to fall. Jamming them, oh, before I forget, jamming them is, you know, just sends them back and returns them to home. The coolest thing I've ever experienced, and I'm not sure, I know people know it's out there, it's public knowledge, so I'm going to say it. Right, Phantom 4 Pro, right, that I fly, my own personal drone. I've experienced, so I'm flying here, right? I can't say where, can't say anything like that. And what they did is they set up an area, so it is possible to set a zone, right? Let's say the zone is here, right? If you stay outside the zone, you're safe. However, if you enter this little zone here, right, at a certain point, the system goes, that's a Phantom 4 Pro, and what it does is, it literally gives the drone a new home point. So let's say your home point was here, this is where you're flying, right? So let's say Bruce is flying here, and he's entered some airspace he shouldn't have done. This system takes control. Now, the home point is here, okay? The drone, however, that's now here, isn't going to go back to Bruce, right? That's just not going to happen. What's happened is, they've set up a new home point over here, okay? Here's a new home point, and what they've done is they've put a skip just here, okay? And the skip does one thing. It catches all the drones. So the Phantom 4 Pro now is going to fly over here to its new home point and go into the skip by itself. And that is technically possible today. Okay, today that can be done. Okay, and I've experienced it, so can't say where, can't say how, but it has been done to me. It's amazing the kit that you can come up against, given the, well, when asked. And if you turn off your transmitter and try to reboot your transmitter, all it says is disconnected. All you can see is disconnected. You can't see where your drone's going, your transmitter has no controls, ATI does nothing for you. There is suite that you can do to get your Phantom 4 Pro back, if they do that to it, by the way. Absolute bugger all. It's quite surreal, to be honest. Right, that's my thoughts on this. So that's the drone corridor. That's, yeah. I'm now just, I would say wasting videotape, but it doesn't really count, does it? 'Cause it's just... Please call again.